Until last weekend, the weather much of the summer has been remarkably regular, almost on a 7-day or so cycle. Weekends have generally been sunny with low humidity, while most of the rain and the higher humidity has occurred during the weekdays. For example, let's take a look at some data. Here's average daily dew points in 2 cities going back to early June. Harrisburg's in blue, Pittsburgh is in red. Remember, the lower the dew point, the more comfortable it feels. Now let me add in the Saturdays and Sundays, highlight them. Notice there's a pretty good match between the lower dew points and the weekends. Now, I admit it's not perfect, but for the weather, especially in summer, when we can go long stretches stuck in the same air mass, this is a pretty regular rhythm. To explain this, we can appeal to the work of a famous meteorologist named Carl Gustav Rossby, the only meteorologist ever to appear on the cover of Time magazine. Rossby studied upper air waves, the troughs and ridges that control the surface highs and lows. And he used a very simple wave pattern and showed that if you stay in the mid-latitudes, the speed of these waves depends on 2 things. First, the wavelength, which is simply the distance between 2 troughs. And second, the average speed of the upper air westerly winds. Now, the wind typically blows through the waves, so the waves don't move as fast as the wind. And Rossby derived a formula that bears his name and works like this. The speed of the waves is the wind speed minus a number that depends on the wavelength. And we can use this to help explain the rhythm of the weather this summer. Now here's the average upper air pattern during a week in the middle of June. This map is like the ones we show you all the time on Weather World, except the North Pole is in the middle here, so you're looking at the entire northern hemisphere. We want to focus on waves in the mid-latitudes, so we'll add the 45-degree latitude circle, and we can estimate the number of waves around the globe by counting the troughs in the mid-latitudes. And let's take a look, 1, 2, 3, 4, 5, 6. So 6 waves around the northern hemisphere in the mid-latitudes. Now we can look at the same map for mid-July. And again, we once again see 6 troughs, 6 waves encircling the mid-latitude. So this 6-wave pattern has been pretty consistent. Now to use that formula, we need the wavelength of these waves. So we'll take the circumference of the Earth at 45 degrees latitude, that's about 17,000 miles, divide by 6 waves and get a wavelength of about 3,000 miles. Now we need upper air wind speed. I took an average over the mid-latitudes for June and July, about 35 miles per hour. If you plug these numbers into that formula, you end up getting a wave speed of about 16 miles per hour, which is about 2,700 miles per week. Now remember, the waves are about 3,000 miles long, so at that speed, it takes about a week for an entire wave to move by, and that helps explain the approximate 7-day rhythm in the weather this summer. Now typically it takes an unusual storm to knock the weather into a different tempo. In this case, it was that highly anomalous upper air low that formed about 10 days ago and moved west into the Great Lakes, causing an atmospheric traffic jam and ending our streak of low humidity weekends this past Saturday and Sunday. Paul Knight's up next to look at this coming weekend in the extended forecast.